that's a little better. Okay.
That's awesome.
So, yeah, so y'all seen me before. You have to look at the thing. Like, here's the real thing here, right? Okay. So, what awesome pencil. What I want to do next is I've got several more demonstrations about density. We already talked about how density can affect whether or not something floats. And let me start over here. Whether or not something floats. And we just learned that if something's going to float in water, what does its density have to be? Less than what? 100. Yes, it has to be less than 1 because that's what water's density is. And if something sinks in water, even if we don't calculate the density, we already know that the density must be more than water's density, which is 1 gram. Yes. So here's what I'm going to do. I've got several demonstrations that I'm going to do. I'm going to have you make a prediction. The first one I'm going to do, I have some ice from the cafeteria. Miss Snodgrass brought me some ice, and I've got a cup of water. And what I'm going to do is put the ice in the water. On your page, just somewhere in the margin, don't let anybody see, write it really tiny. Do you think the ice is going to float or sink? You can put an F or an S if you want to. You think the ice will float in the water or sink in the water? Look my way when you're ready.
What kind of ice is it?
It's just ice. It's regular ice. It's from the cafeteria. Just regular ice cubes. It's regular ice cubes.
Okay.
What? Oh, what do you need? Okay, so if we take that surprise part away from them, then it's going to be harder for them to remember it. So make sure you don't talk to anyone. I'll know who did, because I already know exactly who's had this lesson here. So, you've made your prediction about the ice and the water. Let's see if you were right. And it floats. Yay! Now, draw what you see and label it. Notice that the ice is not floating on top, but close to the top, so that tells us its density must be close to 1. Yes, it's got to be close to 1 probably. So, we're going to draw this. So I'm going to draw. Draw the ice cube. Hopefully yours is better than mine. And I'm going to label everything.
Suzanne Marmer, please call 1001. Suzanne Marmer, please call 1001.
Now, I want to talk about this because we all know that water and ice are made out of the same material, right? They're both made of water. Ice is just water when it's a solid. I don't want you to think that most materials are less dense when they're a solid because that's actually not true. Water is a very special substance. It is actually less dense when it's a solid than it is with liquid. It's a good thing because think about this. What if I sank in water? Think about what would happen to the things that live in rivers and lakes and oceans in the winter when it froze over. What would happen to the plants and animals that live in the water when it froze over if I sank? Avery. Yes, they would be crushed. Yes. So it's amazing to me that water has this property that's actually less dense when it's a solid, and because of that, all those things continue to live, and our ecosystem doesn't get out of whack. Now, I want to talk a little bit about density because we said that density, if something's less dense, it'll float in that material. And to me, it's a lot like arm wrestling. Have you ever arm wrestled someone before?
Yeah.
So, when you arm wrestle, you don't have to say, just nod your head yes, tell me yes. When you arm wrestle someone, you get up on a table or some surface, and, it's always unfair to me because I'm left-handed, everybody else is right-handed, they never want to do the left side, right? So, you push against the other person's arm. Whoever's stronger can push the other person's arm out of the way, right? And they win. Density is the same thing. Picture the denser materials being stronger. It pushes the other material up above. So in this case, the water ice, give me ice, is denser than the ice because it pushed the ice up above. Okay? And we use density in a lot of different ways. One way that we use density is like a submarine. So you know how a submarine is able to lower itself and then also float on top? What a submarine does is it adjusts its density. Its mass stays, its volume stays the same. But when it wants to go down, it opens up part of the hole underneath there and takes in water. So therefore, it increases its mass, but keeps the volume the same. So now it's denser and it goes to the bottom. When they want to go to the top, what do you think they do? Let out the water. Same volume, less mass, now it's less dense and it can float. Another interesting way density is used is in nature. I know you know how fish are able to, go to the top of the water and then go to the bottom of the water. But have you ever seen a dead fish? Yeah. What does a dead fish do? Where does it float, sink, what?
Float.
Yes, it floats. So that lets me know that fish, normally they float in water, but they're able to stay on the bottom if they want to. Fish actually have an organ, a special organ for this called a swim bladder, and it actually helps them adjust their density so they can go to the bottom really easily and stay down there all day if they want to. So that's kind of cool. And then, of course, when they die, they quit working. So we just saw the ice and water. Now, let me do it again. Let me keep that one there. It's already melted. I don't want to do. So let me do it again. This time, I'm going to take another piece of ice. And before I put it in this time, I'm going to blow on it. Yes. And it sinks. Wow. Here's what I need you to do. In your scientist notebook, what I need you to do is write down why you think the ice sank this time. In your scientist notebook, write down why you think the ice sank this time. Okay, back with me. So share with me, why do you think the ice sank this time, but it didn't the first time? Cole.
Because the water, because it kind of melted and it kind of
So he's saying it melted it and it made it sink. Okay. Ian, what's your idea?
Because there was hot air on the ice and when there's hot air on it, it can melt.
So that's the same thing he said. Any other ideas? Jacob?
It raised the ice's mass.
So it raised the ice. So now I like where Jacob's going. That didn't happen. He said he's thinking maybe somehow that raised its mass. If it raised its mass, that's going to make it denser, right? And so that would cause it to sink. At least that makes sense that it would sink. Laura?
I think the ice sank because cold things float and hot things sink.
Cold things float and hot things sink. Do you have any experiences to back that up?
I'm on swimming and when you swim, the water's really cold, so it makes your body really cold. But once you're under the water, your body gets used to the water and your body gets hot.
What do y'all think of what she said? Does that make sense to
So
you?
what?
Aiden?
Like when you're at the campground shop and they've got a hot tub.
Wait. Aiden's got the floor. Go ahead.
And they've got like a hot tub and you get in the hot tub and then you jump back in the pool, then it's easier for you to.
Okay, so we notice a big one, your body's adjusting, getting used to that temperature, so it doesn't feel as cold to you. But if cold things sink, then once you got cold, you would just sink to the bottom, and once you got warmed up, you float to the top. Any other ideas? I think let me grab the ice here. Put it right there. I think if I bring this closer to you, you might get an idea of what's going on here. Don't say anything once you figure it out. Yeah.
I don't think it's out.
Say anything, guys. You're not to say anything.
I didn't know. What's it on?
Now does anybody have an idea why the ice sank?
No.
Braden.
It's alcohol.
It's not water at all. It's alcohol. I just said I had a second cup. I didn't say it's water. Now, notice what ice does in alcohol. What does ice do in alcohol? It sinks. But what does ice do in water? It floats. So water is denser than ice because it was able to push it up. Is alcohol denser than ice? No, the ice pushed the alcohol up. Let's draw this and write down the explanation. Fresh water, no alcohol, no sneaky stuff going on right here. I'm going to put a crayon on it. You think it's going to float or sink? Is everybody ready? Let's see if you're right. It sank. Draw what happened. So it sank. This crayon's density has to be greater than 1 because it sank in the water. Now, the other day, sit up, baby. The other day when we had our clay and it sank, we were able to make it float. How did we make our clay float? We changed its density. We changed its volume and that changed its density. Does anybody have an idea about how we could make the crayon float? What could we do to make the crayon float? Talk to your neighbor first. So Eli, what's your idea? How could we make it float?
That we should melt it
Yeah? And why would you want to melt it?
because it adds more volume.
Yeah, so we could remember how we reshaped our clay? So if you melt it, we could put it in a shape that maybe had more success in floating. Now, okay, even if I didn't know what Caden had done, there's another way I could get it. Why would putting it in salt water make it float, Caden?
Because the salt makes it float.
See, I see. Now he's just told on himself because he saw what was on the board. That's why. And so did a couple other people, but at least they didn't raise their hand. Yeah, I still have the drawing up for line group. So he said the answer, but he doesn't know the science behind the answer yet. He will. So let's go that approach since he's already given it away, not in the order that I wanted it. That's my bag, so I should have had it erased in there. I forgot to erase it. One way to make the crayon float is what Eli said. We could change the density of the crayon. But we could also do what happened with the alcohol. The ice floated in water, but it sank in alcohol. Why did it sink in alcohol?
Because it was
The alcohol had a different density. So instead of changing the crayon's density, we could change the water's density. Yeah. Now, if we put alcohol in it, though, it's still going to sink. Because if alcohol can't make ice float and water can, definitely not going to be able to make that crayon float, right? Because it's even less dense. So what we need to do is make the water denser. Now, remember, to make it denser, we have to either change the volume and keep the mass the same, make it take up more space, but keep the same amount of matter there, or keep the same amount of space there, the volume, but change the mass. What could we do to make this have more mass? What could we do to make this have more mass? Jacob?
Put the salt in it because it would dissolve.
Yeah, now if we put the salt in it, at first it's going to change its volume a little bit, but once we keep stirring, it's going to do what? It's going to dissolve. So the volume is not really going to go up. So let's do that now. I've got some salt, and I'm going to put quite a bit of salt in it. And you can kind of see where the water level is right now. And I'm going to use my marker to stir it up. Let me pause. It's not all dissolved yet. So now I've got salt in there, and some of it's still on the bottom. And now the crayon floats. Why does the crayon float down? It's not floating on the. It's still floating. It's just not floating on top. Why does the crayon float now? Caden?
Because the salt joined with the water, and since the water couldn't hold the crown up, the salt is getting the extra power to the water.
No. What makes things float or sink? Not something getting power. The density. So why can the water push the crayon up now? Will?
It has more density.
Yes. Why does it have more density? Because we added what to it?
Salt.
Salt. What property did we change? Well, it takes up the same amount of space. We didn't change the volume. We changed its mass. Yes, we put more matter in there, didn't we?
it's cleared up.
Oh,